going to talk about getting data, storing data, and linking data. So we've already covered before scoping piece of the project, right? How do we think about the goals of the project, the actions, the data, the analysis, and the ethics. And so we're at the point now, hopefully, where we have a good idea of how would we scope the project and what are the goals of the project, how are we going to change something. And so the first part in actually starting the project then is to start looking at the data. And data is not the most critical piece of the overall project, but it's a necessary piece. Without the data, we can't really build something that's evidence-based, that's database. So the data, having data is necessary, but not enough and not sufficient to achieve the goals of the project, as we covered in the scoping piece of the lecture. So what we're going to talk about today is going to be how do we get data when working on these types of policy projects or business projects, and what are the challenges we normally run into when we're trying to access, collect data. How do we store this data? It comes in all sorts of forms, and how do we store it, where we store it, what are good ways, bad ways, and then how do we link different pieces of data together. And most of the projects we're going to do, we're not going to get one source of data. We're going to get different pieces of data about people, places, organizations from different sources, sometimes conflicting, sometimes augmenting what we know from one place. And so how we link those pieces of data together to get a complete picture of what's happened is really important. And so those are going to be the three critical pieces we're gonna cover today. So to get started with what are typical challenges when trying to get data, and these things are not just challenges you're going to face if you're collaborating with an organization, with a government agency or nonprofit, but even when you're inside an organization, there are going to be a lot of political challenges that you might have to think through to get access to data, because the project you're trying to do may have data that might never have been looked at by anyone, so people are uncomfortable with knowing what might come out of it, or there might be other issues surrounding. So one of the projects we were doing a few years ago was working with police departments on identifying police officers who were going to go on and do unjustified use of force, unnecessary shootings, injuries, things like that, things that we don't want them to do. And even though the project was with police department to help them identify officers who were at risk of doing those things to ideally prevent them from doing so, getting access to that internal police data took a little while. Had to go through the city council for approvals, and a vote had to happen, and the police department, the police officers had to be on board, and trying to deal with that wasn't just signing a contract and getting data, but really trying to understand, well, who are the people involved and how do we convince them that this is the right and the correct thing to do.
Yeah, and that kind of the actors and stakeholders, when you're thinking about this, right, the police example is a good one, because you had the DOJ who might have had a consent decree with the department saying you have to make some changes, and often these sorts of predictive systems were part of those changes. Then you have kind of the internal dynamics of the police, which might include sort of kind of their internal affairs, but also the officers who are out there, and then city council, the mayor, and the public at large. So I think in any organization, especially where you're kind of talking about internal change or oversight, you might encounter this, say, if you're working even with like a nonprofit or NGO, where maybe some of their funders are interested in doing, more program evaluation or understanding how well things work or how they should allocate their resources within the organization, and they might want more autonomy. So I think there are kind of lots of different aspects to these sorts of challenges, and often, maybe even sometimes not where you'd expect them to come from, because there were other police departments, right? I know you can speak to where they were very interested in being more, or at least maybe where the leadership was, was either more or less resistant to this sort of work, and that could really change how successful a project could be.
Right. And I think sometimes what the political reasons result in is not a blanket getting access or not getting access to data, but getting access to certain things, but not to other things, because that might be a politically sensitive topic or data source that they're a little worried about, what might come out of it. So then the question for you while doing the project is, do you need all of that up front? Or do you think you can start doing something with what they can give you access to, and then use the results to sort of, and to build trust and get the other piece that might be controversial at that point. But I think it's important to understand sort of who are the different people involved, as we talked about last time in the scoping piece of, who's collecting this data, who does this data really belong to, and what are the different types of people in the organization who need to be involved in making sure that you're able to get access, not just the which we're going to get to soon, the contractual legal piece of it, but actually getting to it. That's kind of important. The second piece is internal awareness. You might think that if you go to an organization, ask them, and you're working with them, that they have a data set somewhere, a data source, a database that they can just give you access to. And it turns out, no organization knows what data they have. Different people know different parts of the data. Different departments, different individuals might know about certain pieces of data, but most of this data is not sort of nicely organized, stored, inventoried in one place where you can just go and say, tell me what you have, and I will tell you what you need. And often this is sort of back and forth where you're working with somebody, they'll say, well, tell us what data you need. And you're going to say, well, tell us what data you have. And they're not going to know what data they have. And you're not going to know what data you need because you don't, and you'll sort of keep going through this. So again, the way to sort of think about this is really first talking to, again, different people in the organization to understand what data they might have, what data you think they should have, and then help them find that data in their organization. There was one project we're doing with Chicago Public Schools several years ago where we were helping them figure out how to allocate budget resources to different schools based on how many students were going to be enrolled. Because the budget allocation happens, let's say in March, April, May, but students show up in September. And so if you allocated X amount of, if you allocated $1 million to a school based on enrollment predictions, and only half as many students show up, which does happen, you've over-allocated the money. That means you've under-allocated to a different school where more students are showing up. You can't take away $500,000 of money from the school in the middle of September because they've already budgeted for that. And so this game happens every year in a lot of schools, which is ridiculous. But one of the things we're helping them with is trying to understand, anticipate what the enrollment was going to be. And what they kept telling us for almost 6 months was, well, we actually don't know what programs we run in each school. We'd asking them, well, you must know what programs you run in each school, because that's a big factor in who's going to enroll in the school. And there was no centralized data source. I think 6 months into the project, we were at a meeting and we again brought this up. It's like, well, only if we had the programs that you were running in each school, we could do a much better job of predicting enrollment. And this guy says, yeah, I have that spreadsheet on my laptop. And it was totally sort of random that person happened to be in this meeting and happened to have that data on their laptop. But that's sort of an example of, there's no again, you would think the more mature organizations have centralized databases, and yes, they do, but they still may not have every person know what's in that database, how reliable is it, how complete is it, where it came from, what it's being used for, and if there's a conflict with some other data source, which is the right one, because a lot of these data sources are very distributed inside an organization, within individuals, within different departments.
Yeah, and probably another aspect of kind of internal awareness here is data kind of means different things to different people. I think, sometimes, especially if you're scoping a project, really just working with kind of the policymakers or leadership, they'll say, oh yeah, we have, tons of data. And then you say, oh, well, can we get a hold of that? And they'll send you these like rolled up PDF reports with some pie charts or, bar graphs or something like that. You say, well, this isn't really what we're talking about, right? We kind of need the level, 2 steps below this. So I think, this kind of really actually also, really all of these pieces touch on scoping issues that we kind of talked about before, where you want to think about who are all the stakeholders in the organization and who are the people, even as you scope the project and think about the data sources they have internally, how do you chase down what they have and what they think they have, but they actually don't, and things like that as you try to figure out whether a project will be, workable.
Yeah, I mean, I think the top down, bottom up is a really important distinction. Is, people higher up in an organization think they probably have more data than they actually do, because again, the definition of data is very different. A graph or a table or some PDF is data where somebody did a one-off thing to give them that report, and that means they think they have data, which is why it is bringing together people who actually manage, collect, organize that data into organization tells you what you actually have, and they may not be the same. So we're thinking through the political issues of getting access to the data we need, thinking through just knowing what's there and getting a better idea of what's available. Then the part of pretending to be a lawyer comes in, where there are going to be legal and contractual issues around getting access to that data. Some legitimate and some not legitimate. So you're often going to have lawyers throw acronyms at you to give, for reasons why you can't access that data. And again, some of those are very legitimate reasons. And some of those are not, because people are going to be afraid of it's extra work, it's extra risk. With a lot of benefit, obviously, to do this work, but it's still extra risk to access this data. And so what we kind of have to be familiar with, not experts in, ideally experts too, but familiar is what are some of the legal and contractual obligations we have if we access a lot of this type of data. We have to kind of know what the security policies we need to have are. How do we keep the data secure, confidential? And that's one of the reasons we've been emphasizing over and over again, even in the first week of classes, of keeping all the data secure and confidential. Why it has to be behind the 3 layers of, where you have the VPN, then you have to tunnel through this, and you have to kind of keep all the data on the server, and you can't download all that, because that's the legal and the contractual agreement we have with the organizations that are sharing their data with us. So we want to make sure that we deal with that correctly. At the same time, we also want to make sure that those restrictions are not being used as an excuse to not give data. So here's a pop quiz. Who's heard of HIPAA? I'm assuming most of you. The question you want to ask is, how many P's are in HIPAA? It's one of my favorite questions to ask lawyers when they tell me, "Oh, we can't give you this data because of HIPAA." Oh, that's too bad. How many P's are in HIPAA? Most people say 2, and that's great, because actually there's only 1, which basically tells you a lot of the people who are going to use HIPAA as an excuse have probably not read HIPAA and don't know what's in there. It's just a thing for them to tell you so that you cannot access health data. HIPAA actually doesn't talk about not accessing data. HIPAA tells you the rules and regulations around the use of that data. And it's actually a good, I mean, it's worth reading through some of that. It's very long, you know, the regulations. But it basically says, if you're going to use this data, here's what it can be used for, and here's how you protect it. And that's something you want to be, you know, FERPA is another one, which we deal with quite a bit, and that's the educational equivalent of rights and privacy of education and student data. And there's CJIS for a lot of the criminal justice data. And so there's a bunch of different regulations around the use and storage and security of data. But you kind of have so you can have an informed conversation with people, and then end up with an agreement, a legal contractual agreement that allows us to help this organization achieve their goals. Again, right? That's why we're doing these projects, is there is a larger social goal, and we're trying to help this organization achieve it within the constraints that we have, the legal and contractual constraints.
Yeah, and then, oh, sorry.
No, go ahead.
But kind of also in practical terms, there's a lot of, like, you know, often with projects that we've done, right, we're pretty flexible about getting data doesn't necessarily mean, say, you know, them transferring data into our infrastructure. And sometimes, you know, I think working with HIV patients who were at risk of falling out of care in Chicago, we were working on their infrastructure and they gave us access. So then they had all the protections for that very sensitive data that they needed. Even a project that we're working on right now with Code for America out in California, looking at individuals who are applying for the SNAP food stamp benefits out there and other needs they have. We're again working on their infrastructure, and the data is actually also being sort of de-identified to a degree. And so there are kind of many different steps you can take where, okay, even if they're not you know, comfortable with kind of, say, transferring over fully identified data into external infrastructure, you can kind of find ways where you can still work with them. Now, there are trade-offs in these. For instance, if, as we'll talk about record linkage later, right, if the data isn't well deduplicated, or there are many sources where you have to link, then a process of de-identification would mean any of that linkage has to happen upstream of that. And, you know, there's organizations we worked with there. I think there are even organizations that have effectively hired us as, you know, unpaid interns, and then, you know, put us through training and things like that. So I think, you know, one is certainly knowing what are the actual, you know, real legal constraints out there about what you can and can't do and how you have to protect the data. And then two, also being able to be flexible about the way that you'll work with it and the way that you'll work with the organization to make the project work out.
Right. I think the other piece it's important to think through is often when running into these types of, you know, sensitive, confidential, individual level data, when we're sort of trying to get access to that data, one of the things you might hear back from this organization, well, can we just give you aggregated data? Or can we give you totally anonymized data where we remove a bunch of things? And the question for you to think through is, will that data be useful and enough to do the work that you need to do? And so in a lot of the projects that we're considering, for example, the one Kit was talking about for Code for America, doing outreach to connect people with social services that they might need, or the police example of intervening with a police officer, or the HIV example of doing outreach to an HIV positive patient to get them to come back into care. All of those are individual level interventions. Again, going back to scoping, you know, the actions and interventions are individual level. So if we don't have individual level data and we don't have identifiable data, then we can't give this organization the information they need to take action, right? Now, we don't need to know who this person is. We need an identifier that we can give this organization so they can then link it to the individual's data and contact information, right? And if you think about it, hospitals have this information and they use it to contact us, right? Like you've gotten calls and emails and messages from the hospital. So they do use individual level data to do outreach and contact. And the question for us is, if we need that level of data in order to achieve the goal of the project, then we just have to figure out how to make it work with, again, how to keep it secure, how to keep it confidential, and what are the right legal and contractual vehicles. Just as a example, right, most of the contracts that we have with organizations that we work with, governments and nonprofits, we will tell them, we want individual level data. We can de-identify it, which we'll get into a little bit. We will keep all that confidential, but we will open source the code that we write. We want to make sure that we're able to share that code and the code is reusable. And we want to be able to talk about the work we're doing. We don't want to keep it a secret. And that's pretty much most of our contracts that with these organizations, they cover the confidentiality of the data, but they allow us to open source the code and to be able to talk about and write about the work that we're doing so that it can be reused by other people. Yeah, so the next issue, challenge, thing we have to be concerned about are the ethical challenges around getting different types of data. And I mean, one way to think about, there are many issues there, right? The obvious one is the privacy. Is we're getting access to individual level data about their health behavior, about their education history, about their employment history. That is sensitive, confidential, personal data. And so we have to be extremely careful around the privacy issues, around consent issues. Are we allowed to, and some of it is connected to the legal pieces and the contractual, but some of it are, even when you're legally allowed to do something, should you do something? Are there concerns so for example, a lot of the data, for example, if you take information from publicly available information, let's say, if just because Twitter data is available publicly, should you be able to scrape it, get it, and use it for whatever you want? What are the ethical issues around that? Is there an expectation of privacy when using those platforms? And what is our responsibility as people doing data analysis projects to deal with such types of data? If there are images that are on Instagram or Facebook, can we download those images if there's no, if they're public? Some of it, again, some of the things are protected by terms of use and privacy policies of those sites, and some of them are not. And so issues around just because data sets are available somewhere, should we be able to do whatever we want with them? Just because something is public, do we still need consent from people in order to access it? What does consent look like? Is it a one-off sort of fine print somewhere that you get them to check to do in the beginning, and then you can do whatever you want afterwards? Or is it consent every time you're using this data, asking them, can I do this, can I do that? Those are, a lot of them are kind of open questions that again, we need to think through and discuss with again, different stakeholders, the people who are being affected, the people whose data it is, the people who are collecting that data, the people who are going to be using that data. What will that data be used for? It's not blanket use for everything. We're going to have to figure out, this data will only be used to provide this preventative service to this person from this organization. And for example, one of the projects that we're working on right now, the last few years, has been with a county in Kansas called Johnson County around mental health outreach to reduce jail recidivism. And a lot of the data being used in there, the understanding, the expectation that we have with them is that the information we're giving them can only be used by people to do mental health outreach and nothing else. The police will not have access to that data. It will only be used by mental health corresponders to go and do preventative mental health outreach. And that's an important part of these projects, is to think about all the issues that come with that. Let's see. Yeah, so, and that's a bigger topic, and we're going to get into some more ethical issues as we go go along later today, but also in the next lecture. The one final piece of this challenge is, if once we've figured out everything around what are the political issues and what data exists, and we've an agreement, and we've started discussing the ethical pieces of being able to use or collect or do something with this data, the question becomes, how do we technically get this data that's coming from this organization, and what is the machinery to take it, not just one-off, but repeatedly update it, process it, store it, link it. And so we're going to kind of move on and go on to that topic next. So the first question really, and this is going to be, again, if you're working, this is going to be different if you're inside an organization or if you're working with an outside organization. If you're inside, there is data sitting inside. Again, in all of these forms, it's not going to be that just because you're inside, you have perfect, nice, clean access to some data. You still might have to figure out, if you're inside, you might have to actually scrape data yourself probably, and sometimes it's much easier. It's happened many times where even from the inside, it's easy for somebody to give you data by just saying, here, it's on this website, go scrape it, than getting it out off a database. But if you're getting data from collaborators from outside or external organizations. And so most commonly, the ideal form is that the people you're working with have data in some database. That probably will happen maybe half the time, where there is some, not one database, some collection of databases, right? It's very, 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 very rare where somebody has organized all the data into one database, structured for analysis purposes. Even when it's in one place, it's structured for processing, requests. Like, to take right now the whole disaster with unemployment claims being processed, right? The delays that were happening, weeks, months of delays. That's what you've probably heard about, when COVID happened, unemployment rates went up, unemployment claims came in, and our systems weren't ready to process them. And that was a problem for processing purposes. But unemployment claims are also a sensor for government agencies to figure out the employment situation, the economy. And that delay, of course, the much worse impact of it is really on the people who are not getting their checks on time. But also for any type of policies that are being made by looking at that data, there is that delay. And that the database, those systems are designed for processing unemployment claims, not for data analysis. And so most of the time what we're going to find is that data is in a bunch of different places. In the ideal case, it's in a database, because that means that somebody has already thought about what columns you should have and what rows and what the tables are and how they're connected. And there's a little bit of consistency in how that data is structured. So ideally, you want them to give you that database dump, a backup of that database. Different databases have different forms of doing that, right? But something that preserves the structure that was already designed, the constraints that were designed. And so that's the ideal thing to ask for is, if you have it in a database, just give us that database. Some places have, for example, unfortunate things like SAS, where it's living in some proprietary format that's not readable by anything else, or difficult to read by something else, or it's sitting in some text files, right? So that's the kind of the other place you're gonna get data, another format of data, because it's easily convertible. People will convert it to flat files, text files, CSV. And there are always going to be issues with that, where you'll be having extra commas, and you're going to have extra quotes, and you're going to have weird characters, and sometimes the new lines will be missing, and all sorts of things, right? So that's going to be another piece. And then sometimes you're going to get an access to an API, which is not as common, but it's a lot more common for data that's kind of publicly available. So you might have Census Bureau has a bunch of APIs to get ACS data, which is also available in text files, but it also, if you want to get on the fly data then you can get API access. A lot of the social media platforms have APIs available for that. And so typically you sort of get data from either kind of some web, you might web scrape, you might do API access, you might have text files, you might have spreadsheets, you get spreadsheets and spreadsheets and spreadsheets. You might have, Microsoft Access files that you get.
Yeah, I mean, I think there's a whole lot of, well, horror stories really that we could tell here about, even where it seems like the good case where, oh yeah, the data's in a database, if it's in different types of databases or the type of database that you want to work with is different. Like we've certainly had things, where they give us a dump of a SQL Server database, and then we need to somehow port that over to Postgres, and either we're writing a lot of code. I remember one time where we had to dump things to flat files, but because the data was so dirty, ended up using the ASCII bell character as the delimiter. And so then anytime you outputted the file to your terminal window, it would just
Beep, beep,
beep, beep, beep, beep at you, yeah. So, so even where it looks good kind of on its face, it can get pretty messy. The other thing I'd say to watch out here is even if the data is in a database, it doesn't mean that the history is being preserved, right? They might be overwriting fields as the case status updates and changes. We've certainly seen that. And then, when you say, well, I want to go back in time and say, if I was making predictions a year ago, how things would look, well, if all the case statuses from a year ago have been overwritten, you're going to face some real challenges there and have to evaluate how you can work with the data. So I think that's something that we'll talk a lot more about when we talk about leakage and some of the modeling challenges in the future, but it's just a thing to watch out for. This is maybe a good place to put in a plug for our data maturity framework. So if you've read some of our Scopy materials, which we assigned for last week, those link out to some organizational and data maturity kind of writings that we've done about how to think about that, which I think can be kind of useful.
Yeah, one of my favorite stories was years ago, we were working on a project with the school district on identifying students who might undermatch for college. So go to a college that's don't apply to colleges that they can get into that are better, and end up in a college that's let's say with a much lower graduation rate. And they kept telling us, oh, we have all our data in Teradata, and we kept assuming they meant Teradata. Like, okay, it's a reasonable database. We'll figure something out how to get it out of there. And then they gave us access to Teradata, and Teradata was this student information management system that was totally proprietary with this clunky front end. There was a company that was going out of business, and it turns out that we figured out it was a database backend to it, but that was 600-700 tables, of which 400 of them were empty. But we still have to figure out like how is this stored and how is it connected, and so just because it's in a database doesn't make it great. You still have to figure out what the structure is, and often when these systems are made, it's not because the people using them, the people you're working with, didn't design that structure. They just sort of entered something from the front end. And they only use it from the front end to do reports. They're not even sure where the front end matches, where the back end matches, what fields, what they see in the screen match what's in the back end. So that's going to be another piece that you're going to have to figure out, is when you get data, the field names may not make any sense. And we're going to come back to that.
Yeah, just a practical tip here as well. When you get an extract, count the number of tables and count the number of rows in every table, and then send that back to the person giving you the data and make sure it matches, because we've been bitten by that many times. One of the housing inspection projects we did, I think, was San Jose. Somehow there was some setting where their database dump only extracted tables that were smaller than a certain number of rows. So we didn't get any of the tables that actually we needed, or any of the actually useful tables that had data populated in them. And only, right, but this was another one of those systems with like 1,000 tables in it. And so that's not immediately obvious unless you say, well, here's, here's the exact set of things that we got from you. Does it match what you think you sent us?
Yeah, I think that's just generally a good thing to do, regardless of how you get data. Is when you get data from somewhere, do some spot checks, do some kind of rough statistics, and then repeat back to them. Here's what I got. Does that match what you sent me? What you think you sent me? Because assuming that you got everything might not be a good idea, because that's always an issue. So the next question is like, how much, we're going to go through some of these things quickly, right? Like, you don't want anybody to do any processing to the raw data before you get it, because then they are adding things in there that for two reasons. One is you are losing context on sort of what happened. And so you want the rawest, we always tell people, give us the rawest of the rawest data, right? Don't do anything to it. Because if you do something to it, then again, there's two reasons. One reason is that you want to start from where the data comes into the system. Second is that whatever pipeline you're building to do analysis should rely on kind of getting this data repeatedly. So the next time you want to do a refresh, say at the end you end up deploying a system that's updating every day. Now, if they had done some manual processing before they gave it to you, now that manual processing has to happen every day by them before the data is usable by your pipeline. And you don't want that bottleneck in the middle, right? So you want to build that pipeline so that the processing happens as part of your system rather than somebody else has to do it manually. Also, when this extra step of process, so an example of process might be, oh, we removed all the people who we didn't have some information for. Like, well, that's a call you might want to make later downstream in the project, but not up front.
And usually this is coming out of like, oh, we want to be, oh, our data is so messy. You don't really want you don't want the raw data. It's terrible. Like, but I have all this stuff that I do to make it usable. So I want, it's trying to be useful, and you should, have that conversation and listen to that, because there's a lot of knowledge there. But you still want the raw data, and then you can, integrate any of that sort of knowledge about the nuance and the weirdness of the data kind of in your ETL processes and how you create features and things like that. But yeah, usually this isn't coming from a, oh, we want to hide all these things from you. It's coming from we're trying to be helpful and clean things up for you before we send it. But often that's kind of not the best approach for what you want to do with it.
Yeah, and again, the reason for that again is that you want to build what you're doing. The way to think about what you're doing is you're not doing a one-off analysis of generally, like you're building a system that's going to do some analysis and inform again the actions that we talked about repeatedly. And so the data pipeline you're building is something that's going to refresh the data, every minute, every hour, every day, every week, whatever that frequency is. And so think about that data pipeline that you're building in that way. It's going to be run repeatedly, and updating the data so that your downstream components of your overall system can take that and continue to work with it. So the last piece here is that you're getting what you're getting. You're getting what this organization has, what they've been collecting. If it's a school district, they have a lot of student data that they've been collecting on grades, attendance, disciplinary actions, graduations, or if you're, for other projects we have, if you're doing the project with EPA of prioritizing inspections for facilities, the data is really, here are all the facilities, here are the inspections, and here are the outcomes of those inspections. And the question you want to ask often is like, is the data that I'm getting enough? Should I be collecting more data? Should I find new data sources, or should I design new data collection processes? Should I do a survey to either to do the analysis or to validate the analysis? And so that's one piece is we're going to often start with existing data that some organization is giving us, but not be limited by it. Because we have external sources of data that we can connect to, and we're going to talk through sort of census data and ACS, and other sort of sources, like, if you're dealing with 311 data from cities that give you, again, another sensor that's available to understand what's going on. Again, noisy and biased sensor, but we can try to deal with that issue. This question is, something to think about here in your projects is, do you have enough data to get started? And at the same time, when would you collect more data? So if you're working on the project for identifying students who need extra support to graduate, what data are you seeing that's missing that you wish you had? And is there a way to collect that data? There's a couple of data sources like that where you're going to have to think through, if you had that data, what could you do with it? So now that we have data, we're going to have to store it. And yes, we can store it in a million text files and spreadsheets, or if you're, again, if you like to torture yourself, you can use SAS or Stata files. Ideally, you want to use a database whenever possible. It's a good way to store data. It gives you a lot of benefits. We're not going to spend, this is not a cost. Some databases, but you probably should take one. And some of you have taken database classes, others. Databases are extremely useful ways of storing and analyzing data. And there are lots and lots and lots of different types of databases. As far as we're concerned, there are kind of two high-level types of databases. They're kind of relational databases that are kind of row and columns, which are the ones we're going to use in this class a lot. They use SQL for querying, so that's Postgres is the database we're using for this class for the projects. There are other SQL-ish databases, MySQL, Microsoft SQL Server, Oracle, Teradata, and then there are variants of that on the SQL ones that are kind of more, a little bit newer, used for more analytical, large-scale computation, things like sort of Redshift, Vertica, and yeah, I'm missing probably missing
Snowflake, maybe.
Yeah.
The other, yeah.
So those databases, kind of the main thing to think about them is they're kind of giving you this tabular form, right? They are, and you have to specify a structure. You have to specify what tables are there, what entities exist in your data, what columns, attributes you have about those entities, and how those different tables connect together. So there's an upfront work. You've designed the structure. That work is actually useful for you to understand the data anyway. If your data, again, is students, your primary entity is students. So you're going to have some sort of a student table that has a student ID and student attributes, their name, their address, demographics, and as Kit mentioned, some timestamp as the date as of which that row was true, because their address is going to change, the demographics might change, the other things about the student, their name might change, and so again, you want to make sure that you're supporting those types of things, and supporting history and updates and things like that. And then you're going to have other types of information about students. So you might have an attendance table. And if you're not careful, you might sort of think about attendance as, oh, for this student, I'm just going to say, how many days they were in class that semester. Well, maybe you want something that's a little bit more finer, right? Maybe you want one row per day, per student, but you might have, student ID and date, and then was this student there or not? It could be a binary column. Maybe they were only there for half a day. They came in the morning and they had to leave. And this is not something I'm making up. That's actually what, in many student information systems, there is number of hours they were there in school that day, because students do sometimes, they may not be there for the entire day. And the nice thing about that is you can have additional pieces of information about the attendance, and it's much more fine-grained, so you can then aggregate at the level of, how many days did they miss in a week, or how many half days did they have, or how many partial days. Anyway, so stepping back on the relational databases, SQL databases, sort of you kind of specify all of that, and along with that, along with this sort of structure, come benefits of, constraints. That so you when you enter data that doesn't match their constraints, it gives you an error. So it kind of forces you. It's rigid, but it forces uniformity, which makes it easier to do analysis afterwards. And then we're not going to use those databases in class very much here, but then there are kind of more NoSQL type databases that are designed for generally sort of more flexible, faster speed, but less designed for analytic analysis purposes. A lot of the web apps that you see are supported in the backend by those databases that are really optimized for sort of insertion and retrieval, but not necessarily analysis. And a lot of them don't actually support SQL, so you have to write kind of custom code to be able to do things in there. They're not traditional sort of SQL databases. We're not really going to use a lot of them in class, but again, it's worth looking at some of those databases, because you will use them in most things that you do at some point.
What if like all of my data is video or unstructured text or something like that, like which again, not something that we'll maybe do in too many of although the Bill Passage project has a lot of text data, like best practices that you highlight there, or thoughts?
Then you get an intern to code it into a structured database. You say just write down, just transcribe it, and then you're done. Yeah, that's a good point. If your data is all text, like I guess you could just store all of the text in a SQL database, and each you could have a field that is the bill text, and you have the dump all the text in there. But there are also databases that exist that are optimized for certain types of data. So I guess your options really are, you can go 3 directions. You can squeeze, most databases, most structured relational databases have a field type that's called blob, right? It's sort of like you can put whatever you want in there. If it's an image, you put an image. If it's a video, you put a video. They can't often do anything with that blob, so it's just really a dumping ground. And so you could do that. So all the other columns tell you, when this video was recorded. The metadata can be in all the fields, and then you have this actual video in there. Option 2 is you take that video out of there, put it on disk, and that field instead of the blob could just have a path where that video is stored. In practical, it's not much different. It's just now the benefit of the blob is that you have everything in the database. So if you want to transfer it for portability purposes in one place, but analysis is really going to happen. You have to retrieve that blob and analyze it outside the database. The pointer to the text file is another. It's just you have to then carry the entire file system with you, porting it over. And the third is, for certain things, there are databases that can do analysis on that type of data, in which case it's worth looking at that, right? So for example, for the bill passage, predicting which bills are going to pass project, maybe we're thinking about something like Elasticsearch. That is another type of sort of database which does do some analysis with text, and that might be worth looking at. Yeah, so I think in general with data that is not rows and columns, there are other options to look at if you run into them. So same for graph. Another type of database that we didn't cover is sort of graph databases that are kind of optimized for doing graph operations. Things like Neo4j. And so if you're doing work with graphs, that might be network analysis that might be worth looking at as well. Yeah, so one thing here that we want to mention is, again, because a lot of our data is going to be individual level and personal, one practice, again, one common practice, because we want to be able to, if you're getting, again, student data, we might be getting student identifiers and their names and possibly social security numbers. And you don't need many of those things to do the work you're trying to do, but you need them in order to then link it back to the data that the school has in order for them to do the interventions they need to do. And practice is to do de-identification by taking the unique identifiers and hashing it And so it's a one-way hash where you take it and you convert it to a sequence of characters. And so a name and associated number combined together might hash to a 30 character alphanumeric sequence. That's the unique hash, and it's a one-way hash. You can't get back from that hash to the initial name in SSN. But now when you give this, let's say I identified 100 students that I need to enroll in an after-school program, if we gave those hashed identifiers to the school, they could now go from all their students and hash and do a join. So they can do that process again and identify which students to enroll. Whereas in our analysis, we're protecting the identity of these individuals in case some accidental data disclosure happens, in case something or people can't go back from there. So it's something again to make sure that if you don't want to have fields lying around in your analysis that are individually identifiable that you don't critically need to do your analysis. And so that hashing is a good step to take when dealing with that data that still keeps the level. Now it's important to remember, we're not anonymizing anything. It's not anonymized, and there's a big distinction. We are just replacing the unique identifier ID with a different ID. It's still that the student may still be unique, and you can still figure out who they are, but this is for a different purpose.
Yeah, and the thing, of course, to be mindful of when taking this approach is if any record linkage needs to happen, that they're either doing it on their side, or if you're going to rely on the hash as kind of a unique identifier within the system. So assume that different records with the same hash are about the same student, that say if capitalization, right, things are being normalized and cleaned before the hash process is happening. Because I think that's something that can easily confound.
Yeah, I mean, in the best case, ideal case, you do the linkage before you do the hashing, because then you can do a lot of the proximate matches and fuzzy things there and then hash. But that may not be easily feasible. So there are tricks to go around it where you hash it in a few different ways, and then you can sort of do matching using some cascading rules and user heuristics, but not ideal. But yeah, so that brings us to the last piece, right, where we've kind of covered how do we get data, where and how do we store it and structure it. But as we mentioned, most of the projects you don't have a single data source. You might get one data source, but even there might be, well, it's coming from different places, or you're augmenting with some external data. Even sort of simple, if you're looking at, again, the running example we're using of sort of students who need extra support to graduate, you might have student data coming from the school. But you might augment that with ACS data about the census block that the school is in, that the students live in. But you also might get data from what's called the National Student Clearinghouse on outcomes past graduation. Did they go to college? How long did they stay in college? How long did it take them to graduate? You might get additional data from the employment data from the state that the school is in on their employment outcomes. If you actually want to connect school education, sort of high school data to college, to employment outcomes long-term to look at the relationships, you're going to have to connect all those data sources, right? You're going to have to connect those students together to their outcomes. And that's kind of where linkage comes in, right? And they're where we're really trying to go. Again, this is going to be a very quick primer, right? This is not that there are really excellent videos, books, papers on record linkage. It's a well-studied area, so we're not gonna give you a tutorial on it. We're going to give you a rough idea of sort of here's the intuition behind the methods. Here are different kinds of methods go. You're going to have to learn how to do some of these things. So this is going to be a very quick overview, right? And And the two uses of it for our purposes, right, are one, this linkage of multiple sources. You have two different data sources that are about, there's some overlap in the entities of students, let's say, and we want to link the records of this student with the records about, from here to here. The second use of it, which is less linkage, it's called, it's more deduplication of, we have duplicates in the same data source. And we're trying to dedupe those to get a single data source, right? So those are kind of the two use cases we use these types of sources for, these types of methods for. And they're similar methods-ish, because think of the first is you have two different data sources with some overlap in the people, and you're trying to say, this record, does it match to one or more of the records here? Whereas in the second case, you're kind of taking the same data set. You take this data, you make a copy of it, and you say, this record here, does it have one or more, at least has one match here, because that's the record itself. But then it might or might not have more records, and if you link it, you're going to sort of then merge. So it's a similar method that you use, but two different use cases: linkage and deduplication.
Yeah. And even in the students' case, right? Even if you're not going out and getting some of these other data sources, students, move schools, right? Within the district, between districts, and if that data is being tracked in different databases, you may need to do some linkage even there.
Yeah.
And I think the other piece about these two, right, is often you're going to be doing both at the same time. And so, I think the approach you take, at least the kind of details of it, will vary a little bit by, do I believe there are dupes on this side? Do I believe there are dupes on that side? Do I believe that everybody in one database is actually in the other database? Is there one and only one match? And that will, dictate things like thresholds and maybe even the approach that you want to take, especially depending on the types of data. The book and the optional readings for this week really is quite good on this topic, and we didn't want to force everyone to have extra reading, but if this is something that you're going to encounter, that's a good reference for you to have.
Yep. Yeah, so just, appropriate to the topic, because we're trying to do deduping, there are lots and lots and lots of ways of what people call record linkage. And they come from different disciplines, right? So computer science has a bunch of methods, statistics has a bunch of methods, the database community has a bunch of methods, the NLP, the text analysis community has methods, and social sciences. And so here are some names you're going to run into if you're doing Google search on record linkage. It's sometimes called matching, sometimes called merge purge, which is a kind of more, dedupe, where you find the same record in multiple places and then you get rid of one. Duplicate detection, deduping, reference matching, and then a very different type of resolution of these two entities in text are the same, where they're referring to the same entity, and so that's kind of co-reference resolution. So that's something you're going to run into when you're doing readings or looking up things. But basically, yeah, as Kit was saying, some of the factors to consider when you're doing this is you're going to have to make certain assumptions about the data, which means you're going to have to understand the data, where it's coming from, each source, to make some of these assumptions. Is there a one-to-one mapping, right? So every record in this data source guaranteed to have one and only one record over here. If that's the assumption you're making, then it makes life a little bit easier, because if you take two records and you get a match score, you're basically going to say, well, I'm going to just take the highest match score, and that's the match, because it's guaranteed to have one match. So, and nothing else needs to be a match, right? So it's kind of makes life a little bit easier, but it may not be realistic. In many cases, you might have one-to-many matches, or 1-to-0 matches, right? Could be that you have no match, where this person only occurs in this data. And so to Kit's point on the students, you might have all the schools in a school district records, and you're trying to find, okay, this student, I saw him in 8th grade here in this school, now they must appear somewhere in the other schools. And it might be that this person has transferred school districts, transferred states, or not in school anymore. And so it could be zero. This person is not a match anywhere. And that's sort of important to know is it going to be a many-to-one match, one-to-many match, one-to-one? What should you assume starting off with? Some of it requires some data exploration and talking to people, again, who understand this data to think through that. So that's kind of one. The other thing to think about is, does it, what methods are you going to use to do record linkage? Because there are many, many, many different methods. Some of them, if your data is really simple, and if you have unique identifiers with absolutely zero or very little noise, it doesn't really happen very often. But if you're lucky, if you have, SSNs and they're unique and they're correct, and then there's no reason to kind of use anything complicated, especially as a first pass, right? Your first pass is you want to get a system up and running. You want to get some analysis, get to some point, and then come back and iterate. And so maybe the first step really is just do an exact SSN match and see what happens. So you might have some simple rule-based system that you can use to do, exact matching on unique identifiers, or approximate matching in some names, first name, last name, address, or you might actually need to do something more complicated that's machine learning based. And then the question becomes, do you actually have label training data? Or do you need to collect label training data? Do you know when two things are a match definitively and have been verified and not a match? So that's one question. The second question you want to figure out is, often these types of systems rely on taking two records and computing some similarity metric. Right? Can you use generic similarity metrics that exist already? So like edit distance type things, or for comparing strings and names, or for example, you can have generic edit distance, but for names, edit distance doesn't really work. You kind of need something that's like more like a nickname dictionary. And that nickname dictionary is not generic for, it's language specific. So depending on where your data is coming from. So you might want to go and figure out, well, maybe my data is coming from this type of area. Like, if your data is from Australia and New Zealand, all the names are going to be shortened to pretty much nothing. And the nicknames are very different than US nicknames for the same longer version of the name. So that might be an issue. Something to think about is, can you use generic metrics for just like edit distance type things, or same for dates, right? A lot of things like transposing digits happens really often in dates. Transposing month and day happens. So it's not a generic similarity metric. It's a very specific for that type of field. And then the last piece sort of is, how will you evaluate whether your matching is doing well? What is the metric you care about? And in some ways, this is sort of a, think of it as there's self-similarity, there's a fractal, right? Where you have a bigger project, you're thinking about the bigger evaluation metric, what's your overall goal? And then you have this mini problem inside your project, which is record linkage. And the metrics might be very similar. What is the metric I care about here? And if I optimize for one or the other, let's say precision or recall, what's the implication on my overall analysis downstream, on the performance of my models, on the bias of my model, for example, and we'll come back to that at the end of this lecture. So those are kind of some questions to think about: is what methods are you using? Simple rule-based starting off with, or you have enough label data, you can build an ML1. What are your similarity metrics? What are the evaluation metrics? And kind of think through some of these things that are described in much more detail in the readings that we have. Yeah, and again, here are kind of, we're not going to cover these in detail. Generally, you see sort of exact match or kind of approximate matching or probabilistic linkage type methods. This is something to keep in mind: is whatever method you use, it will have errors. It will make mistakes. That's just, and the question is, one, how many of them can you fix quickly? And then two, are think about what are the implications downstream of those errors. So think about what are the common reasons for mismatches. Right, that's going to be a really common one if you're doing exact matching. Lowercase, capitalization, nicknames is going to be a really common reason. People have prefixes to names and suffixes and juniors and the first and the second and the third. Some countries force you to have unique names. Take a look at those countries. Some countries don't, so you have entire generations named the same, which is really unfortunate for record linkage purposes. You can have initials. Some people choose to use initials as opposed to their names, which again, for record linkage purposes, is a problem. Punctuation in the middle of names and other types of touches. And this is not just for names. This is also for company names, right? You're going to have like Corp and LLC and Inc. Sometimes they'll exist, and sometimes they'll have just the name. You're going to have spaces, digits getting, transposed.
And a lot of this depends, right? If this is one place where deduplication and actual linkage showing different data sources can really vary greatly. If you're just deduping within some like really kind of official database, some government database or something like that, say employment records or things like that, people are probably using their given legal name. There may be typos, there may be other problems, but you might have less, worry about things like nicknames or even, initials and things like that. But then if you're, matching business license records to Yelp or something, right? People might be talking about, or to other social media, right? People might be talking about a business in very different ways than the actual official record is. And so kind of keeping in mind sort of the data generating process and kind of the norms of one data source versus another can really be important here.
Yep. And again, of course, abbreviations. So keep all of these things in mind. And the way to think about this is really, when you get two records, you're trying to figure out, are they similar? So you want to sort of account for all of these changes in one or the other. If you make these changes, will it become the same? That's kind of what you're thinking about, is your similarity function that you're creating, which compares to records, has to be robust to these types of changes. They have to be. So that's the reason for thinking through some of these things.
Yeah, maybe my favorite gotcha there is just because the two systems have an ID that's named the same thing and looks like it might be the same doesn't mean it's the same. For instance, you might have a voter file that was initially built, state by state, and they used an auto-incrementing ID for people in each state, and then lumped it all together as one big national file. All of a sudden, you have ID1 in California is not the same person as ID1 in Iowa. So I think we've kind of seen a lot of different ways these things can kind of create challenges, and you have to be careful and just know how the data came to be.
And look at the data. Like,
yeah,
never ever do this type of work without looking at the data, right? It's do these two people look the same? Look at the two records, and often you'll see, oh, they have the same address. My system connected them together. They look like they have the same address. They look like they have the same name, but their date of births are 25 years apart. Are they the same? Like, I don't know. It could be. If they were 2 years apart, maybe they've named two kids, the same name, and a prefix or suffix got lost. If they're 20 years apart, could it be a parent-child relationship? What are the other information? Like, you have other attributes about them that could tell you. And many times what's going to happen is you look at these, if that's all you have, you don't really know. So we have to decide what we do with this record. Do we call it match? Do we call it not a match? Or do we give it some sort of a confidence score and say, well, match but I have a medium confidence in this match. And then later on, as you do, again, the thing is, you're not doing this matching for all purposes forever. You're doing this matching for a very specific analysis that you want to do downstream. So every time you're making any decision at this stage, think about, what do I do now? Or what, if I do make a decision now, what are the downstream implications? And what can I do now to keep this decision that I'm making in context so that I can come back later and explore variations on it once I've gone past this stage. So right now the goal is to kind of do the first iteration and move to the next step, and not to build the perfect matching system. So that's something to keep in mind at any stage here in the project. Is the goal is not to be perfect. The goal is to be kind of good enough to move on to the next step, because we will come back and iterate.
Yeah, and I think this is one of those places, the threshold and your tolerance for errors will vary greatly depending on the downstream application. And there you'll want to think a lot about bias and fairness, but also just kind of what's the cost of an error of omission versus an error of inclusion in general, and figure out, what sort of approaches you want to take from there.
Yeah, I'm going to skip through, I think, these things. This is to sort of keep in mind this concept. We're not going to cover it in detail, but as we're talking about matching algorithms, basically taking each pair and giving a score to how similar they are, that can get ridiculously computationally expensive. So if you've got 100 million records in one database, 100 million in a different database, now you're doing 100 million squared comparisons, and that could be expensive to do, especially if you're doing it repeatedly. And so there is a little heuristic people use. The concept is called blocking, and the idea of blocking is, it's purely for efficiency purposes. There's no other gain from it, really. It's just computational efficiency. What blocking basically says these two records cannot possibly be the same, and that's a heuristic that you say, look, if the addresses are not in the same country, for example, and they have in their last name, they have no character in common at all, or doesn't start with the same character, then I won't compare them. Again, any heuristic you come up with has some risk of, you're going to miss some, right? So if you really, 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 really care about getting recall, or you want to get everybody matched, and you don't want to miss anyone, then you shouldn't do any blocking. But then it's computationally too expensive. So it's basically a trade-off that if your database is large enough that you're going to run into computational issues, blocking says, I'm going to look at some heuristics. Those heuristics will allow me to discard a bunch of comparisons. So I'll only compare people that have, let's say, last names starting with the same character, or that have addresses that are in the same city, or that have age within some window. So that's and there are lots of heuristics you can use for that. But that's the basic idea behind blocking: is you take a heuristic that you care about. If it's businesses, you want to sort of take business that opened within some period of time, or has again zip code, things like that.
Kind of a fine line of like too aggressive versus too loose, right? Too loose, and it can be computationally challenging. Too aggressive, if you say, well, I want the birth year to be exactly the same, or even if you're looking only at last names starting with the same character, well, you might run into problems there with typos, or phonetically similar, right? Oh, did that start with an F or a PH? So you can, I think about ways that you can sort of extend that, but it's always sort of a set of trade-offs of how many errors you might make one way or the other.
And again, if you know your data, you have to kind of know your data. Say, well, I am sure that this attribute is not going to be messy. Like, you have to kind of rely on some of those things, right? If you are not sure about anything not being messy, then it's sort of then you can't really cut corners here. And that's just something you have to be very conscious about. Again, at a high level, this is again a very quick overview of if you were using machine learning to do record linkage, it's kind of like any other supervised learning problem-ish, where you have to get training data, and you have pairs, and you label them as match or no match. Something to be careful about is some people will do this automatically, where they'll say, oh, if these two records are exactly the same, then I'm going to label them as a match. And if they're not the same, then I'm going to label them as a not a match. Well, then your model that you build just basically picks up exact matches versus not matches. So you're going to have to actually look at, figure out, what do you label and who labels it? Because we were just talking about, an example where even a human is not sure, are they the same? Are they not the same? And then what do you give it as a label? So that's the first piece. You want to generate some training data. Second is you want to generate features. And the features here are, again, given these two records, similarity metrics of some sort, like distance metrics over different attributes, different combinations of attributes. And then you build a model, a classifier that given this training data, it builds a model. And then given new pairs, it scores each pair as match or not a match. And then you decide, where do you cut off? What is the threshold? And that takes us back to, are you guaranteed a one? Are you sure there's at least one match? In which case, the highest scoring is the match. If there's one too many, then how far down do you go? Do you label things as definite match, maybe match, definitely not a match, and then you carry that confidence score downstream to do the analysis and then come back and the implications of that? So that's the general idea behind doing.
Yeah, and the only thing to watch, or well, there's many things to watch out for here. One I'll mention is, saying, oh, I'll just generate a bunch of pairs to label is actually way more complicated than it sounds, right? Because again, if you have 100 million on either side and you just randomly generate pairs of those, the vast majority are not going to look anything like, they're not even going to be close to matching. So you kind of have a blocking issue there. Ideally, you kind of want to focus, where is that uncertainty, right? Like the exact matches maybe are not super useful for these pairs. The obvious non-matches are less useful. The ones that are more questionable might be more useful.
Yep. So one last piece, which is, again, what we started off thinking about, you're building your data pipeline. And so it's not a one-off, you get data, you process the data and you do analysis and you're done. It's, you get data today and you have multiple sources and you match. And tomorrow, both of those sources get refreshed. What do you do now? Do you run matching again? You rerun the whole process every day as new data comes in? Do you, if two records were a match today, and now another record shows up in this that is a higher match, do you change this? Before these two were linked, and now do you say, well, no, this is not gonna link this, I'm gonna link this? What does that do again downstream? What does that mean overall for your system? Because now matching is not just for the sake of matching, right? Matching is so that you know something about this person and you're augmenting data. What you augmented yesterday, you're now taking it out and changing what you know about this person. That might change how you communicate with this person and what you predict and how you intervene with this person. And that can get extremely messy. So that's, again, when you're starting off your project thinking about matching, this is an important consideration. Is, are you going to have persistent unique identifiers? Are you going to give people new IDs, basically, right? Because you have an ID here and you have an ID here. And now when you match them, you might give them a new ID, but is this ID for this person or this person? Or is it for the matched pair? And if this pair changes, what happens to this ID? That's sort of, it's a messy problem that occurs all the time in real systems that are getting refreshed data regularly from different sources that are both changing. So that's something to kind of keep in mind.
Yeah, and also a potential for leakage here as well of, if you just get a data dump, you do all the matching in that data dump, and then you go back and try to model in the past. Well, the matches might reflect information that was updated in the future, or new pairs that bridge, or new people that come in, as Ray was saying, that are better matches that you wouldn't have access to if you were 5 years ago when you're trying to roll back and imagine modeling sort of as of. So I think, this is just kind of, all of this has really been sort of like a lot of kind of a survey of these methods that are out there, but also lots of things to watch out for. And there are a lot of challenges, especially as kind of time becomes a component.
Right. So recap, right? We were starting with, we figured out the scope of our project. We figured out what the policy, the overall social goals are for our project, what actions can we take to actually change something, what data we might have available, what analysis we have to do, and what are the ethical considerations. So today was really going into the data piece of how do we get data? What are the political challenges? How do we find out what data exists inside an organization, legal issues, ethical issues, and then the technical issues of how do we get data, in what form, APIs, databases, how do we store data, databases, and then how do we link data through record linkage, either duplication or connecting things together. The part we want to cover in class, so here's the question for you guys to think through, is when we're doing record linkage, we're going to make mistakes. We're guaranteed to make mistakes, right? But in record linkage, there are two types of mistakes we're going to make. We're either going to miss linking people together. So this person is the same as this person. So there's some information about the person here, and there's some information here, and we will miss linking them. Or we're going to link two records together that are not about the same. We keep saying person, but generalize person to business or location, or organization, or anything else, right? Or we're going to link two of these entities together that are actually not the same. So we miss people and we miss entities, or we link them when they're not supposed to be linked. What are downstream sort of ethical, bias, fairness issues? What are some of these issues that are going to come up as a result of our mistakes up front? As our system record linkage makes mistakes, what happens 2 weeks, 4 weeks, 6 weeks, 8 weeks down the road when we build our system that are going to be sort of, that might lead to ethical issues, fairness issues, bias issues, or the privacy issues as a result of our errors in doing record linkage. So think about what those issues are, write them down, and then when we do the live class, we'll have that discussion on that topic, and we'll try to do that regularly of things that we're doing now, that the technical decisions we're making in a project. What are the downstream ethical implications of that? Because that's kind of the way to think about ethics in these types of projects, is not at the very end, not just the beginning, not at the very end as a recap or as a postmortem, but really more as we're doing this work, what are the decisions we're making, and what are the downstream ethical implications of those decisions, and how do we deal with them now so that we can minimize and mitigate the impact later on. So that's kind of all we had. Kit, any other last thoughts?
No, I think that's kind of everything. Yeah, hopefully we'll have a good conversation in class on Thursday about some of these issues, and maybe also even, I know a lot of the students in our class have done different types of projects in their own work, and so where you've seen these things and possible implications of them as well.
Yeah. Okay. Well, talk to you guys soon.